In number 10, we want to find the intervals where f is concave up and concave down and inflection points. So for that, we'll use f double prime, and we'll do a plus minus analysis on f double prime. All right, so let's find f double prime. We have to start by finding f prime. Okay, we just do the power rule here, 3x squared plus, all right, bring down the 2, it cancels with this 2 over here, so we just have 5x minus 14. Okay, that's f prime of x. Let's do the second derivative now. So here we have 6x plus 5, and we want to know when is this equal to 0, and subtract 5, divide by 6, and we would get x equal minus 5 over 6. And now for the plus minus analysis, just put that minus 5 over 6 on the number line. We're looking at this. Substitute in something larger, like 0, for example, over here, and we get positive. Substitute in something smaller, like minus 1, and we have negative. So that means here the curve is concave down, and here it's concave up. And this is an inflection. Okay, again, we're doing concavity, so that's second derivative. Okay, first we need to take the first derivative. And we have 4 times 3, that's 12x cubed, plus 12x squared, plus 12x. We want to know where is this equal to 0. Oh, sorry, not yet. No, we're just going to take the derivative again. We're doing second derivative. Just take the derivative again. Okay, so let's do that. Here we have, bring down the 3, we have 36x squared. Bring down the 2, we have 24x plus 12. Now we want to know when is that equal to 0. Let's factor out 12. All right, so we have 12, and here we have 3x squared plus 2x plus 1. Now if you try to factor this, we see we won't be able to, so let's check b squared minus 4ac and see if it's negative. If it's negative, then we have no real solutions. All right, so let's try that. So b squared, that's 4, minus 4ac, that's 3 times 1. 4 minus 12, okay, that's negative. That means that this is never 0. That means that this f prime is always either concave up or concave down. Well, all we have to do is substitute in one value and we see it's positive. So that means always concave up. In number 11, we're finding end behavior. So we know that we just take the quotient of the highest powers. So we're going to write as x goes to infinity, x to the 5th over minus 2x squared. That's equal to x cubed over minus 2. Well, that goes to negative infinity. And as x goes to negative infinity, x cubed over minus 2 goes to positive infinity. All right, so that's the end behavior for A. All right, let's look at B. Okay, so that's that one. Let's look at this one at B. All right, now here we have, again, just take quotient of powers. Square root of x over square root of x squared. So let's just write as x goes to infinity. What's that? Square root of x over square root of x squared. That's equal to, if we reduce, 1 over square root of x. And that's going to go to 0. And x can't go to negative infinity because negative numbers are not in the domain. So that's it. That's it for the end behavior. Just x going to infinity. All right, in this one, we're going to take the quotient of the highest powers. And we have 7x to the fifth over 3x to the fifth. Well, that's just equal to 7/3, and that stays at 7/3. All right, so that's a horizontal asymptote at x equals 7/3. And as x goes to minus infinity, it's going to be the same thing. Let me mention that here we also have horizontal asymptote at y equals 0. All right, here just look at the highest power. Okay, and we'll say as x goes to infinity, minus 3x to the 16 goes to negative infinity. And as x goes to negative infinity, minus 3x to the 16 is going to negative infinity as well because of this even exponent over here. All right, this part goes to positive infinity, and because of the negative 3, the whole thing goes to negative infinity. All right, so there's some end behaviors.